Okay, well, now that you have done the video, or I'm sorry, now that you have gone to the link, hopefully you came up with something that looks like this, where you have the 2x squareds, and then to get the 5x's, you could separate them like this. You'd have your 3x's going this way. This one would have to have 2x's. Since there's 2x squareds, you need to fill up both of those. You can't just leave this one floating. So you would know that your top number has to be an even number on this one. And then that gives you a spot for 3 little ones, which is what you're supposed to have. Now let's talk about what this would look like. Oh, well, first let's continue to factor it. I'm sorry. So think about what the dimensions would be. If this is an x squared, that means it's an x times x. This one would also be an x times x. This one would be a 1 times x. All of these would be. And then these little guys, 1 times 1 is 1, so those would be the area. So then, looking at that, you have x plus 1 times 2x plus 3. So when you look at it when you're factoring, you'll see, that's why I use the color here to match it up into these 4 parts, into these 4 squares. Okay? And then I starred these because these are going to be the ones that you're going to be able to complete first on generic rectangles. So I just want you to start seeing that connection. Okay, flipping it over to the back. To factor with tiles, like you did in part A, you need to demonstrate how the tiles need to be arranged and to form a rectangle. Using a generic rectangle to factor requires a different process. So Miguel wants to use a generic rectangle to multiply 3x squared plus 10x plus 8. He knows that the 3x squared and the 8 go in the location shown at the right. So that's what I was talking about on the other side. Like, you're always going to know the first and last go here and here. So you can confidently fill those out. And then it says, finish the rectangle by deciding how to place the other 2x terms and then write it as a product. And so I went down here and I saw, well, if I have my 3x squared, and then I know I need to have 8 little guys here, how can I rearrange these 10 rectangles? And this is the way that it works. And so you'll see here there are 6 x's, and so I shaded them in blue, and then here there were 4 x's, so I shaded them in red. And then just to come back and check Casey's method from the last lesson here, are the diagonal products equal? 3x squared times 8 is 24x squared. 6x times 4x is 24x squared. So diagonals are equal, and that's going to become a huge part as you're factoring. So let's move on. Kelly wants to find the shortcut to factor 2x squared plus 7x plus 6. She knows that 2x squared and 6 go in the corners of the rectangle as shown here. She also remembers Casey's pattern for diagonals. Without actually factoring yet, what do you know about the missing 2 parts? So, if you have these set up, you know that the diagonal product has to be 12x squared. So that means you need to be able to multiply these things up to get 12x squared, and you need to be able to add them to get 7x. Well, here is why we have been doing the diamond problems all year long, because you know how to find those things by looking at diamond problems. To complete her generic rectangle, you need 2 terms that have a sum of 7x and a product of 12x squared. So create and solve a diamond problem to represent that situation. So, what 2 things multiply to be 12x squared that add to be 7x? 3x and 4x. And so then now you're able to complete her factoring in her generic rectangle, because you know that those 2 would have to be a 3x and a 4x. So then when you put them in there, 2x squared, what gives you 2x squared? 2x times x. 2x, you're going to want it to go on the side where you have the 4x, and because you can't multiply 2 to get, or by anything to get 3, at least that's an integer. And so 2x times 2 is 4x, x times 3 is 3x, 3 times 2 is 6. So you get 2x plus 3 times x plus 2. And tune in for video number, I think, 3.